students, in this video you are going to learn about the basic functional units of a computer. In a computer, input unit, output unit, memory unit and processor are the important functional units of a computer. Okay, whereas inside the processor, ALU unit, registers and control unit are the important internal components. With the help of these components only, the processor performs all its operations. Coming to the input unit, it is used to read data from the input device. The examples for input devices are keyboard and mouse. Okay, this input unit, it reads data from input devices and transforms the received data into encoded form. Then that will be stored. It stores the encoded content in binary language inside the memory, which will be further processed by the processor. Whereas coming to the output unit, it is used to send the processed results to the outside world through the output devices such as printer, speaker and monitor. The next functional unit is memory. Here the memory unit, which is here shown in this diagram, is known as main memory, which is directly connected with the processor. Okay, the memory unit which holds the instructions and data which are currently need to be accessed by the processor. This, in other words, we can say like this also. So whatever the instructions and data to be processed by the processor must be available inside the main memory. Okay. However, main memory is the primary memory, one of the important memory. In addition to main memory, there are other types of memory also available. They are cache memory and secondary memory. Cache memory, it is used to store frequently and recently used data and instructions, which is smaller in size and faster in access. Okay, it provides faster access speed. Access speed, I mean better than main memory. That's why this cache memory is, in the latest computers, cache memory is integrated with the processor chip, but it is not the internal component. Okay, it is integrated with the processor chip. That is, its distance to the processor, it is lesser than main memory. Okay, since it is attached, it is integrated with the processor, its distance is lesser than main memory. Okay, so whenever any instruction and data need to be accessed by the processor first checks the cache memory. Okay, if the required information or data is available in the cache memory, then it access from that. When it is not available, then only it goes to the main memory and access the required content. Because the main purpose of cache memory is to avoid the time delay, that is reduce the access time that happens if the processor directly access from the main memory. Why the access time may be more compared to the access time of the cache memory for the processor? Because the main memory, it is the external component, its distance is more compared to the cache memory, because cache memory is integrated with the processor, as well as main memory size is bigger than cache memory. Okay, since cache memory is integrated with the processor, its distance is less, as well as since it is size is smaller, the access time will be reduced compared to main memory. Okay, so just now we discussed about the primary memory, which is also known as main memory, which is used to store all the programs, that is collection of instructions and data currently being processed by the processor. Okay, all the active programs and data must be available inside the primary memory, and other than the active programs and data will be held inside the secondary memory only. That will be the secondary memory holds all the data and instructions which are not currently in use by the processor, but which may be required in future usage and for long-term storage purpose. So whatever the content need to be maintained, that will be maintained as a backup in the secondary memory. Okay, coming to the processor, the internal components of the processor are ALU unit, registers and control unit, right? So this ALU unit, arithmetic and logical unit, it performs all the arithmetic operations and logical operations There is examples for arithmetic operations are addition, subtraction, multiplication, and examples for logical operations are and, or, not, and all the comparison operations. That is, in short, we can say that all the computations which need to be performed by the processor is done with the help of a unit only. Okay, next coming to the registers. Registers is the smallest and fastest storage unit, which is the part of the internal which is the part of the processor, and it is the internal component of the processor, and it sizes too small compared to all the other components, and its size is capable of holding only one memory word. Okay, for example, if in a computer inside the memory many memory words will be stored, right? If the memory word size is 32-bit, then the register capacity also will be 32-bit. That is, the registers will be capable of holding only one memory word. Okay, the registers are used to store temporarily. These are used to store temporarily store data and instructions and memory addresses. There will be many registers like a program counter register, memory address register, memory data register, general purpose registers, instructions registers. Okay, so each register's capacity is of one memory word length, and they are used for storing some specific data like instructions and memory addresses that we will discuss in the subsequent classes. Okay, so you need to remember the registers are the smallest and fastest memory unit, which are the internal component which is built into the processor, and is the internal component of the processor used to store data, instructions and memory addresses which are required during program execution. Okay, this is one of the important point. Whereas coming to the control unit, it controls all the other components like registers, ALU unit, memory unit, input unit, output unit. All the components are controlled, coordinated and synchronized through the control and timing signal of control unit. Okay, one more important concept that you need to remember while learning functional units of a computer is memory hierarchy. Okay, here the memory hierarchy is illustrated in this diagram. Here all the memory units including registers are arranged in the memory hierarchy. If you look at this memory hierarchy, the smallest memory unit register is at the top, and the biggest memory unit is at the bottom. Okay, so when we move from top to bottom in the hierarchy, the size of the memory units grows bigger, whereas when we move from bottom to top, its access speed and cost of the memory units grows higher. Okay, that is, smallest memory unit is registers, which can hold only one memory word length, and cache memory is somewhat, it is bigger than registers, but it is smaller than main memory. Okay, so as well in this memory hierarchy, these are also arranged based on the distance from the processor. Okay, the registers are the internal components which are inside the processor, whereas cache memory is it is integrated with the processor chip, but it is not the internal component of the processor. Whereas main memory, it is the external component of the processor. Okay, so compared to cache memory, its distance is more from processor, whereas secondary memory, its distance is more than main memory. It can be removed from the computer also frequently, just like our pen drives and hard disk. Okay, and in this memory hierarchy, one more important concept: when we move from bottom to top, the access speed and cost of the memory unit grows higher. Okay, the access speed of the secondary memory or auxiliary memory, it is very slow compared to the other units which are in the top level of the hierarchy. So the very fastest memory unit is registers, and it is also more expensive. The cost required to access per bit information from the register is more costlier, the costliest compared to all the other components. So this is about the basic functional units of a computer, students. If you find this video useful to you, kindly subscribe this channel. Thanks for watching.